This is Michael from Blue Sky Bio. I'd like to welcome everybody who's joining us for today's presentation. You should be able to hear me clearly through your computer speakers. If you have questions during the presentation, please feel free to enter them into the chat box and I could address them during the presentation. Below the viewing screen, below the viewing video, there's a link. Please enter your details into the webinar attendance form so that we could send you the CE credit in a timely manner. Today's presentation, we're going to be discussing fabricating surgical guides with the Blue Sky Plan software. Blue Sky Plan, for those of you who may not be aware, is treatment planning software. It could be downloaded from the Blue Sky Bio website, and it could be used to fabricate surgical guides for all implant systems and all guided surgical kits. The software is free to use for treatment planning. You could design the surgical guide directly into the software. When the surgical guide is done and you're ready to export it, then there is a small low per case fee just for the export of an STL file, and then you could send it to a 3D printer. The process flows that we're going to be discussing is very similar if you're a dentist or if you're a lab or a service center. There are dentists that are designing their own surgical guides, and there are dentists that prefer to have the surgical guides designed by a lab or by a service center. There's definitely a need for both. And there are dentists that prefer making their own surgical guides, and there are dentists that prefer having the service done by a lab or by a scan center or whoever's providing the guided surgical service. The main difference in the process is primarily going to be that the dentist might be handling more of a particular type of implants or particular type of surgical guide, and the lab or the service center might be providing more of an array of services, maybe handling a wider variety of cases. But the general process flows are very similar in both situations. The agenda for the presentation is we're going to be providing a step-by-step process of a couple of different situations. The presentations I've given in the past, we're using the Blue Sky Plan software directly showing the cases. This time I decided to use PowerPoint, which has its disadvantages, but the advantage is that the step-by-step process flow being created, if anybody wants to receive it for normal mode, for advanced mode, for a particular situation, we'd be happy to send you that set of slides, and then you could use it kind of as a help to go through the process together with the step-by-step. So we're going to be discussing situation if you're fabricating guides with the Blue Sky Bio parts, and for that we have the normal mode, which you're going to see is a great situation. It's a streamlined process. It removes the need to use any calculations, any numbers. The software is doing it entirely for you. You go through the process, and the result is the surgical guide. We're also going to be discussing guide fabrication for additional guided surgical kits, which is advanced mode. As we've mentioned just a few minutes ago, the software could do both. It can handle surgical guides for all implant systems and all guided surgical kits. If you're using a different guided surgical kit, no problem. There's a couple of different steps or settings in the software. There's no advanced trigonometry or algebraic equations, but there's a couple of numbers that have to be added together, and that could be done using the advanced mode. We're also going to be discussing improved merge technique for high scatter cases. During the process of these three different process flows, we're going to be pointing out some new functionality in the Blue Sky Plan software for treatment planning and for surgical guide design and fabrication. Before we jump into it, on the previous slide, we mentioned the normal panel for Blue Sky Bio parts. I wanted to clarify what that means. We're talking about three main things. We're talking about the handpiece, the direct cut drills, and the implants. We're going to be discussing the process for all three situations, or more than that, if you're using all three of those, or if you're using none of those. But if you're going to be doing guided surgical cases, I think it's worthwhile. Get the handpiece, get the direct cut drill. It's not expensive, but it's going to simplify both your design of the surgical guides, or even if they're being made by a lab, then it's going to simplify your surgery. There's information on the website about the direct cut drills, about how to use them. There are studies as well. Doctors that have used it have loved it with a lot of positive feedback. It removes the need for handles or spoons. You create the osteotomy size with a single drill, specially designed, and then you place the implant. So it's a streamlined process flow during the surgery itself. It also streamlines the treatment planning and the guide fabrication, whether you're actually designing it yourself or you're having a lab design it for you. Okay, so now we're going to jump into the process flow, the step-by-step for the normal mode for guide fabrication. When you load the software for the first time after you install it, it asks which mode you want to operate in. Irrelevant of that, you're able to change the mode by going to the mode drop-down menu and choosing normal or advanced or whatever you like. There's also two different protocols. There's digital surgical guide, which is what we're discussing today, used by the vast majority of users. There's also the model-based surgical guide, which is a great technique if you want to buy a printer that's cheaper because it's not printing biograde material, but it has a high level of accuracy. Then you could print a model with a post coming out of it, slide the metal cylinder onto the post. The post holds the metal cylinder at the exact height, location, and angle. You could do a vacuum press suck down, and that becomes your surgical guide. That's not what we're presenting in the presentation today, but the process exists, and you should know it exists, and there's more information that we could provide both on our website and by contacting us directly. So right now, the process flow that we're presenting is with the normal mode, digital surgical guide, and like I mentioned earlier, and you could see in the guide panel on the right-hand side, it's not asking you to enter numbers or to do calculations. Because you're using the Blue Sky Bio parts, minimally the drill and preferably the handpiece and implants as well, the numbers are set and the settings are set for you. Requirements for the normal mode, we discussed the X-Cube handpiece, preferable, not required. We'll get into that. Blue Sky Bio drills. In addition, you need the CT scan of the patient, and you need the stone model optical scan for guide fabrication purposes. We're going to merge, after the treatment planning, we're going to merge the stone model together with the CT scan, and we're going to use that to fabricate the surgical guide. The reason the stone model is used, the optical scan, is one, the STL scans, these optical scans are the higher resolution than CT scans, and also because a CT scan really has a, you could think of it as a grayscale. It's not either yes or no, it's not either there or not there, but it has a different density thresholds that could affect the shape of the anatomy or of the model, and because of that, we have the STL optical scan, which is either black or white, there or not there. It's much more clearly defined, and it doesn't have the density threshold issue that I just mentioned. Now, regarding the implants, if you're using the Blue Sky Bio implants, that's the ideal situation. If you're using a compatible system, Nobel, Zimmer, Straumann, then treatment plan with the Blue Sky Bio implants and use the indicated parts. Even if you're going to be using a different implant, it will tell you exactly, the software will tell you exactly which drill and which metal cylinder should be used, and will create all the settings properly in the software. So if you're using a compatible system, in treatment plan using the implants from Blue Sky Bio in the library, in the software, and it will take care of that for you. If you're using a non-compatible system, but still in the software, when you go to add implant, you'll see that there's a drop-down that has company names and implants in it. The advantage of doing it that way, if you're using a non-compatible system, is that the software will still tell you which drill and which metal cylinder should be used. It's going to give you a drill that matches the apical diameter of the implant, and you could use it to create the osteotomy. Afterwards, it's recommended to use the implant manufacturer's drill to create the recommended exact size and exact shape, but it will give you an osteotomy that's the apical diameter of the implant, and it's a great way to go. Okay, the first step, it's a simple 4 or 5 step process. the first step is importing the patient scan. We're not going to discuss the details of exactly how to do each step. We're assuming that if you're watching a webinar presentation on fabricating surgical guides, that you have a basic knowledge of using Blue Sky Plan. And if you don't, that's not a problem. We have tutorial videos on our website. You could contact us and arrange a free training session, or you could play around with the software. There are other ways of learning the software. But for the purpose of this presentation, we're assuming that you have a basic working use of Blue Sky Plan, and there are processes that we're going to not go into detail because that's not the focus, and it's not how we want to allocate the time currently. So we're importing the patient scan. We're treatment planning. To detour just for 1 second on the treatment planning process to point out some functionalities and newer features that some people may not be aware of. During the treatment planning process, you're able to add virtual teeth. I think a lot of people know that. What might not be so known is that, first of all, you could choose if you're adding the teeth with the roots or you're just adding the crowns. You're able to select multiple teeth just by holding down the Shift key and left clicking on them. When you place them into the treatment plan, when you left click, it's going to place in that location the tooth that's in the brighter pink that you have there, and the other teeth will be next to it. You have the functionality in the bottom right to place the virtual tooth together with an implant. Essentially, you're treatment planning your cases from a restorative point of view where the restored tooth is going to be, and the implant is placed along with it. When you modify the positioning of the virtual tooth, the implant positioning is modified as well. Of course, you can modify the implant separately, but it's another way of approaching the treatment planning. You're able to choose what size virtual tooth you want to place, and once it is placed, it's a little bit cut off there, but you can see there are nodes, circles coming out of the side and the top, where you can actually customize the height and the width even further. So these are just some newer features and functionalities that will help with the treatment planning process when doing that. Another item that's new in the software that I want to detour and talk about is the ability to import the patient scan. Okay, to the right of the 3D view, your fourth icon from the top, you're able to use it to import a picture of the patient. You can modify the opacity, you can modify the positioning. That's another relatively new feature that I wanted to point out. Okay, the first step in the process, importing the patient scan. The second step in the process was treatment planning. Now we're up to the third step in the process, which is importing the model. Importing the model, we're going to align the model to the patient scan. 2 tips or recommendations before doing that will help with the merge is, number 1, raise the density threshold. Underneath your 3D view, you have the slider. You're going to need to mark the points on the teeth. Okay, so if some of the bone disappears, that's not really a problem. But if you raise the threshold, often you're going to get rid of some scatter or irrelevant parts of the scan, and will help clarify things and improve the merge. Second is to use the isolate or cut button on the bottom right to, again, remove parts that are unnecessary. The isolate tool is a really great tool. You click isolate, you click on the patient, and it removes everything that's not touching the patient at the time. It's not touching what you just clicked on. Okay, we recommend that the patient's mouth be open during the CT scan, even if it's ever so slightly. That will allow the isolate functionality to be used to remove the opposing arch and to allow a merge. Later in the presentation, we're going to discuss additional steps, additional techniques that could be used for high scatter cases when there's a tremendous amount of noise and restorations. But even when you're not in that situation, recommended 2 things. Very quick, raise the density threshold and use the isolate and cut functionality. Then you're going to go ahead and go to File, Import STL. It's going to show you the STL of the model. It's going to show you the STL of the patient. You could use your normal mouse controls to rotate, to zoom. When you want to mark a point, you press Shift and you left click. It doesn't matter the order you place them in. It doesn't matter if you do one on the left, one on the right. But you want to disperse the points throughout the scans You want to mark the same number of points in both scans, and you want to mark them as exactly as possible on both scans. The more points, the better. Some people think that it's going to confuse the software, it's going to throw it off. Minimum of 5. Go ahead and mark more. Distribute them buccolingual, mesial distal, and in the vast majority of situations, this helps tremendously. You're going to have a quite accurate merge. If you check the merge and it's not a good merge, then the first step is to go and to do it again. Go to your model manipulation panel, hit align points again, and repeat the process. Distribute them more, add a few more points in, make it more accurate, and that's the first step of recourse. The second one is we've added in manual manipulation for fine-tuning. The arrows are pointing to some new functionality. We've added in the ability to move any object in the software, whether it's a model, whether it's an implant, whether it's a scan appliance. You could, number one, obviously grab and drag it. Number two, you could use the widget to rotate it. But what we've most recently added in is the ability to control it with the arrows on your keyboard, almost on a pixel by pixel level. Very, very fine tuning. You can also rotate it. You press Alt and the arrows, then it's going to do the rotation. Okay, so the step 3 of the process, after we imported the scan appliance, after we trim implant, we imported the model. If the process isn't an accurate merge, you put in more points and you do it that way. You want to do manual manipulation for very, very fine tuning. Use the arrows on the keyboard. You could also use the Alt, and that will allow it to rotate. Okay, confirming the merge. So now you've got it imported, and how do you go ahead and confirm the merge? So you look at the outline. You could see on the right on the surfaces panel, there's a hint option which creates the outline in the 2D view. You want to look particularly in the cross sections, and you want to look particularly in the axial view. You want to make sure the outline is tightly wrapped around the teeth. In areas where there are no teeth, there's an understandable discrepancy because the CT scan is not showing the soft tissue, and the model, or may not be showing the soft tissue, and the model is showing the soft tissue. So look in the area where there are teeth. Make sure it's wrapped tightly around the teeth in the different views. If you want to modify the merge, we discussed, add more points, manual manipulation, that's the way to go. Okay, step 4, we've imported the scan appliance, we've imported the CT scan, we've trim implanted, we imported the model, now we're ready to fabricate the guide. The 3D view should be in a situation where you're only viewing 2 things. You're only viewing the scan of the model, and you're only viewing the brown cylinder, which is your software guide tube. The brown cylinder represents the placement and the hole of the printed surgical guide. Okay, it's important that to make sure that you have the correct model visible. Sometimes you'll import multiple models with teeth, with teeth, without teeth. You want to make sure you have the correct model visible, or else it's going to be confusing that the software isn't going to respond as you expect it to be if you're working with the wrong model. Another new feature functionality that we've added in that you could see on the screen now is those green semicircle. Is the green semicircle protruding up from the software guide tube? We know what the software guide tube is. That's the hole in the surgical guide. The metal cylinder goes into that brown software guide tube, and now we have the green half a circle protruding up from that. What's the reason for that? The point of that green is it's a built-in drill stop. Instead of having to use an external drill stop and slide something onto the drill or connect it to the handpiece or whatever it is, here you're actually going to be printing the surgical guide that has the drill stop built in and attached to it. It's going to stop the handpiece at the proper depth for the osteotomy that you planned. And when you're using the normal mode, which we discussed the advantages of it, it creates the built-in drill stop at the correct height. You drill till your handpiece is stopped by the built-in drill stop, and you're good to go. Okay, so when you're up to the stage of fabricating the guide, you want to have the model visible, and you want to have the software guide tube visible. You don't need anything else. to be visible in the 3D view. Now we're up to drawing the curve. We have the guide panel open, which again is missing the numbers because it's not necessary, and you want to draw your curve. You could use your mouse functionality to zoom in, to zoom out, to rotate. When you're ready to start drawing the curve, then you hold down the Shift key and you left click and drag. You're going to draw the curve. You're going to close the curve on all sides of the model and teeth, whatever's relevant, and that's where the surgical guide is going to be. It's going to sit on the area that you've defined in the curve. Okay, so when you're ready to draw, you hold down the Shift and your left mouse, you drag, you circle, and then you go back. You go back to the starting point and you close it. Zooming in and out of the 3D, you could use either your mouse, right mouse button, mouse forward, zooms in, right mouse button, mouse back, zooms out. Your left mouse button rotates. You could also use in the horizontal toolbar on the top, there's also the arrow keys, and you could use that to manipulate. The next step is to edit the curve. After you draw the curve, you're going to have what you have on the screen right now, the ability to fine-tune the exact placement. You could grab and drag any of the nodes and to fine-tune the placement. If you don't like your curve at all, then you could hit the second button to clear the curve and to restart it. But if overall you're happy with the placement, grab the nodes, fine-tune them. You want to pay attention to a couple of things. Number one is you want to make sure that the curve doesn't cross itself. It should not zigzag, it shouldn't twist. Okay, you could move the nodes around to help fix that a little bit, or you could redraw it. And also you want to make sure there are no sharp corners, also for the way that it's going to look, and also functionally, you want to make sure there are no sharp points. So you go ahead, you fine-tune the placement of the curve. Now you go ahead after that and you press Create Guide. Boom, a window pops up. What is this window? At the beginning towards the beginning of the presentation, I recommended using the X-Cube handpiece. It was $285. It simplifies the process. And if you're using it, you just press I'm using the X-Cube handpiece. Then Blue Sky Plan knows exactly the length of the drill that's coming out of the handpiece. It does everything automatically. But if you're using another handpiece, you could still use the normal mode. What do you want to do? You want to put the drill into the handpiece and measure it. And what you do then is you change the length of the short drill after you measured it, or the length of the long drill after you measured it, and you put it into the case. If you want to save it as your default settings, then you could do that as well. Once you put it in, the software is going to calculate the built-in drill stop and skin and calculate the drilling depth. It's going to calculate everything for you with your handpiece and with your drill. So if you're regularly using a different handpiece, then you could change it on your defaults in the software, save new settings, and that will be taken care of for you from that point forward. If you're a lab or a service center, if you're handling different cases with different handpieces, you could change it on a per case basis and not a problem. But this is the way that we check to make sure the measurements are correct for the particular handpiece that you're using. Blue Sky Bio also has a chart or information regarding different handpieces and the length of the drill that's coming out of it. We're going to be incorporating that chart into the software, so you just click on the handpiece that you're using. For now, if you want our help, just contact us. We'll give you the proper measurements for your particular handpiece. And this is the way, this screen is the way to allow you to use a different handpiece and still use the normal mode and still have all the calculations done for you in the software. Okay, you fabricated the guide, and this is what it looks like on your screen. In the red box, you could see that there's a new surface that shows up, a new object that shows up in the software in the surfaces panel. We could also see right now we're still viewing the surgical guide on the model with the software guide tube there. That's the brownish color that you see on the surgical guide. I left that in there to show you. This clearly shows that the surgical guide is fabricated exactly according to the treatment planning that you did. Okay, there's no difference, there's no discrepancy of any sort. The hole in the surgical guide is exactly according to the software guide tube. The part coming up from the brown software guide tube, again, is your built-in drill stop. And that's going to control your depth with your handpiece. Here's the surgical guide from different angles. And now we're moving on to the export button. The export button in the normal mode makes it super simple. You don't have to think, what am I exporting, what am I not exporting? You press export, it exports one thing and one thing only. It exports the surgical guide. You decide where you want to save it on your computer. It saves as an STL file, and that is what's going to go for printing for your case. The report button that comes up after export generates a very nice report for you automatically. You don't have to worry about the settings, about what goes in, what doesn't go in. It comes up for you. It gives the details regarding the drill, regarding the metal cylinder, regarding the implant. It shows two values, which is your drill depth, which is the second to right column, and your drill depth with built-in drill stops. What's the difference? You could see here the two blue lines indicated on the surgical guide. The drill depth is a combination of three factors. Okay, the drill depth generally is the length of your implant plus the space between the top of the implant and the top of the surgical guide, which we call the offset, and the lip of the metal cylinder. That's your drill depth. That's how long your drill has to be without any stops on it. The drill depth with the built-in stops is the same thing, but instead of being the upper blue line, it's the lower blue line. That's the value that includes the built-in drill stops. Okay, that's the value of the length of the drill from your handpiece that sticks out of your handpiece to the bottom of the implant. Okay, and that drill depth with built-in drill stops is going to be the drill length. If you think about it, the drill is going to extend and go down from your handpiece to the bottom of the implant. The built-in drill stops, the drill depth with the built-in drill stops is going to be the length of your drill. The next button on our panel is order parts. You click on it and it brings the parts from your case up on the Blue Sky Bio website. If there's something that you don't need, you have the drill, whatever, just red X it off. But it will tell you exactly which drill, exactly which metal cylinder, and exactly which implant is trim implant in your case. Okay, so again, you don't have to go looking things up. You don't have to go doing research. You trim implant your case. The software tells you what you need. The process flow of the normal mode that we just discussed is importing the patient CT, trim implanting the case, importing the model. You draw the curve to fabricate the guide, and you go ahead, export, order the parts, and create the reports. Okay, the process again is a no-number process flow. We recommend it for simplicity. It's recommended to use the X-Cube handpiece, the drills, and of course the implants, because it makes everything super simple, both in terms of trim implanting and in terms of making the surgical guide, and of course the surgery. Additional functionality that you could do using the normal panel as well, if you want to go ahead and fine-tune a couple of things. The brush allows you to smooth out the outside, not the inside, but the outside of the surgical guide, if you want to make it smoother or flatter. And together with that, you could apply a label. If you want to put the patient's name on it or the tooth number or whatever it is, you could apply a label to the surgical guide. It will emboss it onto the surgical guide and be printed out together with the surgical guide. On the bottom of the guide panel is the ability to change the orientation of the built-in drill stops. Okay, by default, the opening is pointing outwards to make it easier to insert the drill from the side instead of having to go over the top. If you want to modify, if you have a couple of adjacent implants and you don't want to modify that slightly, then you could go ahead and do it that way. Just so you know that that functionality exists, and you could fine-tune the STL object of the surgical guide after it's fabricated. One important point that I wanted to point out is this. As once contacted regarding a case, the offset, the software guide tube was raised all the way up because there wasn't room for the software guide tube between the surrounding teeth. Now, it's not a problem if the outside of the software guide tube is colliding with adjacent teeth, because when the surgical guide is fabricated, the software will automatically remove that part of the surgical guide and leave enough room to put the surgical guide on and off. Okay, in that situation, if the inner circle of the software guide tube is not colliding with anything, then there's no problem. You'll be able to insert the metal cylinder into the surgical guide, and there won't be any problems. The software, when designing the surgical guide, will automatically deal with the outside of the software guide tube. What is a problem is if the adjacent teeth protrude into the inner circle and break the inner circle. If you think about it, when the surgical guide is printed and you try to insert the metal cylinder and place that surgical guide into the patient's mouth, you'll have a problem. So this is an important point for clarification. If there is no room, even if there still is no room, there's other steps, other recourse that you could take. You could create the initial guided osteotomy with a smaller drill and then widen it freehand. If you're able to raise the software guide tube up a bit to solve that problem, then that's steps that could be done as well. But this is a very important distinction. If it collides with the outside of the software guide tube, no problem. If it collides with the inside of the software guide tube, then that is the problem. Regarding printing of the surgical guides, if you have your own 3D printer, great. If you don't, there's 2 printing centers that will print the surgical guide for you. They both offer printing of the surgical guide for the ballpark of the $35 range. They also offer services of scanning the model as well, included in the price or for a couple of extra bucks. So here's contact information for printing centers that will print the surgical guide, and you could do the process yourself and have it printed elsewhere. Now that there's a lot of talk about the $50, $60 surgical guide, the numbers in terms of how it works out. Well, you're paying your raw costs are the STL export, which is to Blue Sky Bio, which is in the ballpark of $15. If you buy a larger package, the price goes down towards the $12 mark. If you buy a smaller package, it goes up to the $20 mark. But it's approximately your $15 for your STL exports. If it's a 2 implant case, you're dealing with 2 metal cylinders, and then there's the printing of the surgical guide. Of course, if you have your own printer, then you're just dealing with the materials, and you're coming out with a surgical guide in the ballpark of $60. If it's more implants, of course, it will cost a bit more for the metal cylinders. But the STL export is the same whether you're exporting a case of 1 implant or 6 implants or whatever it is. The STL exports, by the way, can be purchased directly in the software. If you go to File, Purchase STL Exports, it'll connect you directly via PayPal, and it will activate the functionality automatically and immediately in the software. Okay, that was the process flow for the normal mode. Quite simple, using the Blue Sky Bio drills, hopefully the handpiece, hopefully the implants, and it takes you through a process that's quite quick and easy. Now we're talking about the use of the advanced mode, primarily if you're using a different guided surgical kit. Okay, and again, it's not advanced trigonometry or whatever it is, but there's a couple of numbers that have to be manually put into the software. To switch to the advanced mode, you hit the mode panel, you change to advanced, and your guide panel is going to change from what we had previously to a bit of a different panel. What the requirements to do an advanced mode case is your same CT scan of the patient as the stone model optical scan. Here, you're going to need a bit more information. You're going to need to know the lengths of the drill. If it's with a stop, you're going to need to know the length until the stop, and you're going to need to know either the spoon handle information or the information regarding master cylinders. Now, Blue Sky Bio also has some information. We could also help and we could also help with that information. Okay, I'm going to field, before we jump into this technique, we're going to field a few questions. There's a question that came in before regarding implants in the software. We're happy to add any implant system. You know, so if we get the information, then we're able to add it, and we're happy to do so. MegaGen is not currently in the software. A question regarding placing of the implant in more dense bone is something that we're not going to get into now. It's more of a clinical question, and we'd be happy to put you in touch with clinicians that could help answer that question, but I'm not the person to address it, and we're not going to discuss that now. The exclamation mark that comes up on the implants is a validation tool. By default, there's a menu, there's a panel in the software for implant distance between adjacent implants and between the implant and the nerve. There are default settings in the software for 2 millimeters and 3 millimeters. You could change them if you like, but if you see a red exclamation mark that comes up on the implant, it means you're violating a default setting to warn you that implants are being too close together or implants are being placed too close to a nerve. Okay, now we're going to jump back into the advanced mode. We were saying that for the advanced mode, you need a little bit more information regarding the drill lengths and regarding the size of the master cylinders. But again, it's not very difficult, and Blue Sky Bio has a lot of this information, so we could help you with that as well. The process flow, and I know some of it's repetitive, and I did that intentionally. Number one, it's going to show the difference between the two different process flows. And also, I mentioned at the beginning that if you want to receive all or part of the presentation, then we're happy to send it to you, and it will be a step-by-step process in terms of using the software. So importing the CT scan, same as before, no problem. Treatment planning, same as before, no problem. Before we deviated a little bit regarding some additional functionality to import a patient scan, to import a patient's picture, or different tools with the virtual teeth, but we're not going to go through that again. Importing a model, same process flow. You want to raise the density threshold so that it's clear. You want to use the isolate tool so that there's no extra noise or no extra parts, and then you go ahead and you do the merge. You import the points, you import the model, you need to mark the points on both scans. We discussed distribute the points, the more the better, the more the merrier. Okay, it's not a good merge. You go back, you add points, you put them more accurately, you add a few more points, and you do that. In terms of manual manipulation, we said you could either drag, grab, and drag, you could rotate, and newer functionalities, you could use the arrow keys to really move it almost pixel by pixel, and use the Alt and the arrow keys to fine-tune the rotation. Confirming the merge, you want to make sure that the outline of the imported model is very tightly wrapped around the areas where there are teeth. You can look in different views, particularly in the cross-section and the axial view. When you're about to do the guide fabrication, you want to clear out your 3D view. You only want to have the model and the software guide tube there. And that's the step that you're going to use to design your surgical guide. Now, when you're in advanced mode, then you're going to have additional options both in the surgical guide panel and on the implants panel. What you want to do on the implants panel is you want to adjust the guide hole diameter. Okay, that's going to be the diameter of the hole in your printed surgical guide. You want that hole to be 0.1 millimeters larger than the master cylinder that's going in. You're going to be taking a metal cylinder and putting it into the hole. The hole needs to be slightly larger than the metal cylinders that the metal cylinder goes in. We have information, as you can see on the screen, for some systems, which metal cylinders that we have that have the same inner diameter of those systems, and what the guide hole diameter should be in the software in the surgical guide. So the first thing that you want to do, which is going to accommodate the different guided surgical kit, is to change the hole in the printed surgical guide so that you could put in a master cylinder that matches the key or the spoon that you're going to be using. We have online, we manufacture more than 60 different size metal cylinders. Pretty much every guided surgical kit is accommodated. If you need help identifying the correct size, you contact us and we'll be happy to help you do that. But the first thing you want to do when you're using a different guided surgical kit is to change the guide hole diameter in the software. The second thing that you want to do is to change the offset. Okay, this is going to be controlling the depth. We're not going to be using the built-in drill stops, although they could be used and you could enter the information manually. But if you're using a different system that has drill stops built into the drills, you're going to use the offset to control the depth. When you change the offset, you're increasing or decreasing the distance between the top of the implant and the top of the software guide tube. So a very simple example in terms of the drill depth, if you have an 8mm implant and you add the offset of 9mm by default, you get to 17mm. If you're using a metal cylinder that has a lip, then you have an 18mm drilling depth. So if you're using a drill that has a stop at 18mm, perfect. If it has a stop at 20, you increase your offset by 2mm, and now it's matched. Okay, so the math in terms of calculating the offset to rearrange the previous equation is your drill length minus your implant height minus your metal lips. Another thing to consider, when I wrote metal lips, it's not just the metal lip of the metal cylinder, but if a key is going into that and that has an additional lip on it, then take that consideration as well, because that will add to the drilling depth. And again, you need help, no problem. You could contact us. We'll help you walk you through a case or two to get you started. Now, the guide panel in advanced mode looks like this. And again, this is when you're using a different guide surgical kit. It looks a little bit intimidating maybe, but it's really not. And it's what it is, it's the same as the normal mode, but it's providing more options in a good way and in a maybe a little bit more confusing way. But it allows you to fine tune really every element of the case. Okay. First, you're going to select from the drop-down the model that you're using for surgical guide fabrication. Lock implants and virtual teeth, very simple, and make sure that while you're drawing the curve or manipulating to fabricate your surgical guide, you don't accidentally move the implants and the virtual teeth. And this is done by default in the normal. But here you have an option to turn it on and turn it off. Okay, the drill stop posts. This is what we saw, that's the built-in drill stops. In most situations, if you're using another guide surgical kit, recommend turning them off. Uncheck them. The green semicircles that we saw coming out of the brown software guide tubes are going to disappear. The brush diameter. The brush removes any part of the surgical guide that's higher than the brown software guide tube. Okay, and you can see in the picture, it removed part of the surgical guide that's overlaying an adjacent tooth. And the reason is simple. You want to make sure there's no interference from the handpiece, that nothing interferes with the handpiece going to the proper depth. In the normal mode, it's done automatically. In advanced mode, we're giving more options. You want to increase it, you want to decrease it. You could just change the brush diameter. Guide quality. Here, we're allowing the user to control the resolution of the surgical guide. We recommend always using high or very high. It will use up a bit more computer resources. It will use up, will take a couple of seconds longer to make the surgical guide, but we recommend going to high or ideally to very high in terms of that resolution and accuracy of the surgical guide. Okay, the next step that we have is the same as before. All that stuff on a case-by-case basis probably isn't going to change much. And all that stuff, we took the default settings from it and we put it automatically into the normal mode. If you want to change it, you switch to advanced and you make the change. But all of those settings on a case-by-case basis likely won't change that much. when you're making surgical guides. And now we're up to the same process as before. You draw the curve, you go to edit curve to fine tune the placement of the nodes and the placement of the surgical guide. Here again, it pops up asking you which handpiece you're using. And then you press the create guide button and it makes the surgical guide. Once again, we see that the software guide tube and the surgical guide have the exact same hole. There's no built-in drill stop because we unchecked the built-in drill stop selection. And here we have the surgical guide. We could use the brush tool. Again, in the normal panel, we had brush tool with not as many options because we took the defaults, we took what most people are using, and we put that into the normal mode. But here you have the brush tool with a bit more options and control, and you have the labeling tool with more options and control as well. You could see how the text appears from the box in the guide panel to the surgical guide, and you can see how it looks when it's embossed onto the surgical guide. Exporting in advanced mode is a little bit different. In the normal mode, it exported just the surgical guide without thinking, without knowing anything. When you export in advanced mode, you have a screen that looks like what we have now. It's divided into different boxes, and you could export anything from the software. You could export the patient's anatomy. You could export the model. You could export really anything that you want, and this box allows you to do it. The top left is for exporting the nerves if you want to include it. The top middle is to export STL surfaces. Right now you could see the surgical guide checkbox is checked. Whatever's checked will go to the export. The top right is to export the CT surfaces if you want to export the CT scan, the anatomy of the patient. The bottom left is if you want to include in your exports the implants, the abutments, the drill guides. There are 3 different columns there with different checkboxes, and you could go ahead and check and uncheck what you want. And the bottom right is to export the virtual teeth. We've seen more and more applications of being able to export the virtual teeth as well. So this is a more complex control panel for the advanced mode that allows you to control exactly what's being exported. The normal mode makes it simple, gives you exactly what many users want, and the advanced mode gives you more control. You want to control exactly what you want to export. You want to include some things or export something else. You do that here through the export panel. In the advanced mode, we have a dedicated parts panel. Before, you clicked order parts and it opened up the website. In advanced mode, we've added in an extra step. Again, more control, and a little bit less streamlined, but the trade-off for more control. In the parts panel, you could check or uncheck exactly what you want. You could increase or decrease the quantities. It shows you the parts. The software will automatically populate it, and you could go ahead and, when you're ready, hit the add parts to cart in the bottom right, and it brings it up on the website to order the parts. The screenshot panel in advanced mode allows you to customize reports. You could add in different screenshots. You could customize exactly what you want to go into your report. And you could use the button, the save button on the bottom left of the panel to save the screenshots that you currently have in the basket. If you right click on the screenshots, you could remove all. You have different options. Saving it will save the screenshots to your computer. Using the PDF or print options, it opens up functionality that allows you to customize the report. Again, in the normal mode, we gave a built-in report that is helpful to many users. If you want to customize exactly the layout, what goes into the header, what goes into the footer, all of that could be done from the panel. The thing to be aware of is not to rely on the information in the guide report format button. It's going to show you information for if you include it. You could not include it at all, which is probably the best option if you're using a different guided surgical kit, because it's showing you information regarding the Blue Sky Bio drills and how that plays out. So it's important, if you're making a drilling report or making a report for the case and it's not being done with the Blue Sky Bio drills, rather it's being done with a different guide surgical kit, and be aware that whoever's designing and fabricating and whoever's doing the surgery shouldn't be relying on that information. To review the screen that came up before, it's not a problem if the adjacent teeth interferes with the outer diameter of the software guide tube, but it is a problem if it interferes with the inner diameter. And here are the printing centers. Doesn't matter if you're making your guide in normal mode or advanced mode. At the end of the day, you're going to have an STL file to go for printing, and it could be done there with pretty much the same costs as previously. The last process flow that I want to go through for the presentation is a process flow that enables an improved merge and improved stitch. It's going to add another step or two to the process, but especially for high scatter cases, it will ensure that the merge is spot on. And we'll demonstrate in the process flow that what it creates is a process that you're not merging in a situation where there's scatter, but you're always merging to very clearly defined points. The screenshot that we have here and the process in general was done by Dr. Corey Glenn. He gave a presentation probably around a month ago on advanced treatment planning and guide fabrication for edentulous and high scatter cases. In the comments section underneath the video screen, I put the link into the presentation. Highly recommended. We're not going to go into the edentulous cases at this point, but the process, we're going to go through the process of dealing with this type of situation when you're dealing with a high scatter case. Now, the problem, if you look at the screen in front of you, it makes it very clear. The STL scan is a clear scan. There's no noise, there's no scatter, there's no problem with restorations or metal in the patient's mouth, while the CBCT, the CT scan, could have a fair amount of scatter and might be problematic if there's a lot of restorations or artifacts in the patient's mouth. The solution is to use a scan appliance to help with the merge process. Okay, we need to create points of reference to allow the stitching. And the process flow that Dr. Glenn outlines is to use a bite registration. You could put in the dental markers. They're available on the Blue Sky Bio website. And he goes through the process of creating your own scan appliance. You're taking an alginate impression in the tray. You scan the patient with the impression still in their mouth. You remove after the scan and immediately pour up the model. Once the stone sets, then you scan the stone wearing the scan appliance. And then you lastly scan the STL model. We're going to go through the process in the software, but essentially what you're doing is you're creating an additional scan, which is a CT scan of the stone model wearing the scan appliance. And that is going to bridge together the patient scan and the STL model for the merge. And we're going to see that in the software now. And again, there's more detail exactly on how to do this in the previous webinar presentation, and you recommended to check it out. The process flows: you're going to import the patient scan wearing the scan appliance. You're going to CT scan the model with the scan appliance. So that's scan number 2. You're going to merge the patient scan to the scan of the scan appliance with the markers. The markers don't have scatter. So here's where we're initially solving the problem of the scatter in the patient scan. The markers in the patient scan and the markers in the CT scan of the model don't have scatter, and a very accurate merge can be done. However, we don't yet have the STL of the model scan in. So the next step is to import the stone model. And what we're doing here is we're importing and doing the merge of the CT scan of the model, which doesn't have scatter, to the STL scan of the model, which doesn't have scatter. So we're creating a process where we're doing the merge to merge without any issues of scatter. The CT scan of the stone model wearing the scan appliance is the bridge. And if you don't have a CT scanner in your office or nearby, and you're sending the patient out, then the scan appliance can be made not with the bite registration, but with a suck down, either by you or by a local lab, and the patient could take them with them to the CT scan. And then the same process, the patient scanned wearing that scan appliance, the model is scanned wearing the same scan appliance, and then the model is scanned in an optical scanner without the scan appliance. Okay, the requirements for the normal mode with the merge for the high scatter cases. Here you can see there's an extra step. It's recommended to use the X-Cube handpiece, the Blue Sky Bio drills. Here it's CT scan of the patient, which we had before, but here he's wearing a scan appliance. You also have the CT scan of the appliance with the stone model, which is the extra scan here, and the stone model of the optical scan. Now we're going to run through the process flow. The items that were there previously, we're just going to breeze right through. You import this case, the patient scan, you treatment plan, and then you go to File, Import Scan Appliance. You could select the second CT scan, which is the model wearing the scan appliance. The screen opens up, showing the top left is the markers of the scan appliance. The top right shows the markers with the model scan. The bottom left is the model scan itself, which you could raise the density threshold underneath it to clear it up as much as possible. And the bottom right is the merge. The software will try to do the merge automatically. In probably 70% or 80% of the cases, the merge is going to be spot on automatically. If not, then you help the software by identifying the markers. You left click on the markers in both of the top scans, and it creates the merge in the bottom. Okay, and that's how you merge the CT scan of the model wearing the scan appliance into the patient scan. Now we want to go ahead and import the STL. When you go to File, Import STL, it's going to show you the STL file on the right, but it's going to automatically initially try to merge it with the patient. So you go ahead and you press the cancel button. You don't do the merge at this point. You open up the model manipulation panel. You select the model of the STL file. Okay, it's in the software, but it's not merged accurately. You select what you want to merge it to, which is the middle screen. And you use the points technique, just like we did before. The difference being that now you're not aligning the STL model to the patient scan. You're aligning the STL model to the CT scan of the stone model. So once again, you're doing a merge without any scatter involved. The first merge was merging the patient scan to the CT scan of the model using the markers with no scatter. The markers don't have scatter, so that's the initial merge that doesn't have scatter. And then you're merging the STL model to the CT scan of the model, which again doesn't have scatter. Manual manipulation for fine tuning, we discussed that. We discussed confirming the merge. Here the difference is that you could see both scans outlined in the axial view and in the cross sections view. So you see that the outlines of both of them are extremely accurate and overlap each other as they should. We're getting ready from this point on. Now we're doing standard guide fabrication as we saw before, either using the normal mode or it's the same process, the same concept in the advanced mode. The merge process that we went through is the same depending on either, irrelevant of either mode that we're using. Here we're showing it in the normal mode as well. Okay, so you press to draw the curve, you draw the curve, you edit the curve to fine tune the placement. It asks you about the handpiece, and here you see in the surfaces panel all three objects: the scan appliance, which is the CT scan of the model with the markers, the model scan, and the surgical guide, which is now created. If you're using the normal panel and you go to export, then it exports exactly your surgical guide. If you go to advanced, then again, you have the options of controlling what gets exported and what doesn't. The report functionality, same as before. The merge process that we discussed doesn't affect what we discussed earlier. And again, ordering the parts, same concept. When you finish the surgical guide, you could brush, you could add the label, and move forward from there. And again, the fine nuance of what's problematic and what's not. At the end of the day, printing the surgical guide and the costs involved are quite similar. I'm going to be wrapping up the presentation. Our time is pretty much up. If you have questions, then go ahead and enter them. Meanwhile, in terms of contacting Blue Sky Bio for help, we have the plan email address. We have phone support. You could arrange a one-on-one training session. I also highly recommend joining the Facebook group Blue Sky Bio Study Club. There are guys there that are doing amazing things. The cases they're posting are fantastic. There's a tremendous amount of knowledge to be learned, both in terms of clinical applications and in terms of using the software. That's highly, highly recommended. There's the YouTube channel, which we constantly put up information in terms of functionality, webinars, so that's recommended as well. Dental Town, of course, is always a good resource. There's a particular string there that's been going on with hundreds and hundreds of posts, but again, it's contributions from users of cases that are done, ideas, suggestions, feedback, and comments, which are always welcome. The particular strings, the $50 surgical guide. Again, stay connected. These communication channels are fantastic. If you're interested in a live person-to-person hands-on course, there are courses being given on guided surgery using Blue Sky Plan and using the Blue Sky Plan surgical guides, which are, of course, very highly recommended. That pretty much wraps up today's presentation. If you have any questions, comments, please feel free to contact us, and we'd be more than happy to provide assistance. I'd like to thank everybody that's joined us for this presentation, and enjoy the rest of your day. Thank you very much.